Okay, pre-calc students, these are the last problems on your day 2 polynomial notes. So previously we learned that imaginary zeros always come in pairs, so that if negative 5i is a 0, the conjugate of negative 5i is also a 0. So remember that that imaginary zeros or complex zeros, they have a real part and an imaginary part. So you can think of negative 5i as 0 minus 5i. The conjugate of that would be 0 plus 5i. So if negative 5i is a 0, then positive 5i is also a 0. So we can write our factors. If we have a 0 of negative 5i, we have a factor of x plus 5i. If positive 5i is a 0, we have a factor of x minus 5i. So we're going to multiply these two factors together. I have x squared minus 5ix plus 5ix. And then I have 5i times negative 5i, so negative 25i squared. So these middle terms will cancel out. I have x squared minus 25, and I can replace the I squared with negative 1. I squared is equal to negative 1. And then this simplifies to x squared plus 25. So I know that x squared plus 25 is a factor. So next what I'm going to do is I'm going to divide my polynomial by x squared plus 25. Since this is not a linear factor, I can't do synthetic division, so I'm going to have to do long division. So I have x squared plus 25, and I'm dividing that. Oops, I need some more space. So I'm dividing x to the 4th minus 9x to the 3rd plus 43x squared minus 225x plus 450 by the x squared plus 25. So my process is, and you may need to write this out on a separate sheet of paper, x to the 4th divided by x squared. So that gives me x squared. Then multiply the x squared times the divisor. X squared times x squared is x to the 4th, and I put it under its like term. X squared times 25 is 25x squared, and I put that under its like term. And then I need to subtract. So I like to change my subtract to plus the opposite, so I go plus, minus, minus. These cancel. Bring down the negative 9x to the 3rd, and subtract these to get 18x squared. Bring down the next term, minus 225x. Okay, so then divide the first term by the first term. So negative 9x to the 3rd divided by x squared gives you negative 9x. Multiply the negative 9x times both terms here. So I get negative 9x times x squared is negative 9x to the 3rd. And negative 9x times 25 is negative 225x. So change your minus 2 plus the opposite. These both cancel out, but I bring down the 18x squared. And I bring down the plus 450. So I have 18x squared divided by x squared, I get plus 18. And then multiply the 18 times x squared plus 25, I get 18x squared plus 450. So when I subtract, I have a remainder of 0. So this is my answer. Now I need to find the zeros. So you can find the zeros of x squared minus 9x plus 18 by factoring or with the quadratic formula. So I'm going to try to factor. I need two numbers that multiply to give me 18 and add to give me negative 9. So those numbers would be negative 3 and negative 6. So the factors are x minus 3, x minus 6, and those would give me the zeros of x equals 3 and x equals 6. Okay, remember that we also have imaginary zeros. We have an imaginary zero of negative 5i and of positive 5i. So to find the zeros, I'm going to write the negative 5i, the positive 5i, and the zeros we found from factoring, 3 and 6. It says to use the zeros to write the factored form of the equation. Multiply imaginary conjugates to have only real factors. So instead of using these imaginary factors, we're going to multiply those together, and we'll get x squared plus 25 as one of our factors. The other factors come from our zeros 3 and 6, and we can see that those factors are x minus 3 and x minus 6. Okay, so in the practice here, try to pause the video and see if you can write the conjugates before I go on. Remember that the conjugates have the same real part and the opposite of the imaginary part. So since this is only imaginary, that would be a negative 2i. If you have the same real part and the opposite of the imaginary part, then this would be 3 and plus I. Same real part, opposite of the imaginary part, 8 minus 5i. Same real part, opposite of the imaginary, negative 3 minus 2i.